Okay, hi, Assalamualaikum everyone. Alright, so continue again in our tutorial Chemistry for Matriculation SK015 Chapter 6 Chemical Equilibrium Tutorial Part 2 presented by me, Sir Zulhairi Ahmad. Alright, so let us proceed. Okay class, so today kita akan continue untuk discussion number 11. Okay, so 11A, define degree of dissociation. Alright, so degree of dissociation, okay, the definition of degree of dissociation is the fraction. Okay, degree of dissociation is the fraction or percentages, okay, or percentage of molecules that dissociate. Right, so the formula for degree of dissociation is given by alpha, okay, is given to X over C initial, okay, ataupun kalau kita nak percent, okay, percent dissociation okay, percent of dissociation is equal to X over C initial darab 100%. So this is the definition for degree of dissociation. Okay, right. So question B. If 0.024 mole of N2O4 is allowed to reach equilibrium in with NO2 in a 0.372 liter flask at 25 degrees Celsius, okay, given N2O4 gas produced to NO2 gas and Kc is equal to 4.61 exponential negative 3. Calculate degree of dissociation alpha of N2O4. Alright, so the final answer is given 0.12. Jadi kalau dia bagi 0.12, tiada persen, okay. Kalau tiada persen maksudnya dia akan gunakan, okay, we are using this formula. Tidak perlu darabkan dengan 100%. Alright, so for this question, okay, first kita write dia punya equation. Okay, so the equation is N2O4, okay, N2O4 gas dissociate to produce 2NO2 gas. Alright, so the initial concentration is 0.0645 molar, and this is the initial is 0. So where we got 0.0645? Alright, so you are given 0.024 mole in 0.372 liter flask. So kita boleh cari dia punya concentration, initial concentration for N2O4 initial is equal to 0.024 mole over 0.372 liter. Yalah, so dia punya concentration here is 0.0645, 0.0645 molar. Alright, so di sini kita letak 0.0645 molar. So the change is, so tengok di sini tiada perkali, so we just minus X, okay, and then this one is plus 2X. So concentration at equilibrium, okay, is 0.0645 minus X. 0 plus 2X is equal to 2X. Okay, so dan kita boleh write the expression. Okay, the expression di sini ialah Kc is equal to concentration of NO2 square over concentration of N2O4. Jadi kita substitute the value di sini. NO2 is equal to 2x square over 0.0645 minus x. 0.0645 minus x. Okay, ni tiada kuasa. Okay, sebab perkali dia satu saja. So which is equal to, okay, Kc. So the value of Kc given is 4.61. So this one is equal to 4.61 exponential negative 3. Okay, so bila kita expand this equation, this one dia akan jadi 4x. Okay, so 4x square equal to 0.0645 minus x, okay, times 4.61 exponential negative 3. Okay, so biasa kita expand this the equation. Okay, so dia akan jadi, we arrange the equation, 4x square, okay, plus 4.61 exponential negative 3 minus 2.973 exponent negative 4 equal to 0. Okay, so bila kita dah ada this equation, kita kena solve untuk apa? To find x1 dan juga the value of x2. Okay, solve gunakan apa? Quadratic. We use quadratic expression. Okay, kita dah ada quadratic. So this one is okay, so our quadratic expression tadi, okay, kita dah dapat iaitu 4x. Okay, our quadratic expression is 4x square plus 4.61 exponential negative 3x minus 2.973 exponential negative 4 equal to 0. Jadi kita selesaikan untuk x1, kita dapat 8.064 exponential negative 3. x2 we got negative 9.217 exponential negative 3. So obviously we neglect this value. Okay, so this one kita neglect because dia apa? Negative. Alright, so then x is, okay, our x ialah this one. Okay, right, so degree of dissociation is equal to x over c initial. Jadi x berapa tadi? 8.064 exponential negative 3. So initial molarity is 0.0645. Okay, so kita dapat berapa? 0.125. Okay, ataupun the answer given is 0.12. Okay, if the question asks you to find the degree in the form of percent, okay, percent dissociation, apa yang kita perlu buat? Kita just alpha kita darabkan dengan apa? Times with 100%. Okay, so 0.12 times 100%, so we got 12%. Okay, jadi dia sama lah, 0.12 in fraction, okay, and then 12% di dalam bentuk percentage. Alright, so next, so you are given, okay, so this one is for QC, compare Q dan juga KC. Right, at the equilibrium, the equilibrium constant, this one kita nak predict the direction of equation. Okay, kita nak tengok arah tindak balas, sama ada dia forward ataupun reverse. Jadi this one kita perlu compare Q dengan KC. Jadi kita tengok Q lebih besar ataupun Q lebih kecil. Alright, so this one you all should remember, mesti ingat, kalau dia forward, okay, kalau dia less than dia akan forward, kalau dia greater than dia akan reverse. Okay, so kita look at the KC. Okay, the expression for KC is given by KC is equal to concentration of HI square over concentration of H2 times concentration of iodine. Okay, alright, so so this is KC, okay, given 4.18 exponential negative 3. Jadi ini adalah nilai at equilibrium. Jadi sekarang kita perlu calculate the concentration of HI, hydrogen and iodine. Okay, so iodine equal to 0.03 mole over 2 liter. So we got 0.015 molar. Okay, concentration of hydrogen, okay, 0.01 mole over 2 liter. So we got 0.005 molar. And then concentration of HI is equal to 0.04 over 2 liter. So we got 0.02 molar. Jadi kita dah dapat sini dan kita boleh calculate apa? Q is equal to concentration of HI square over concentration of H2 times concentration of I2. Okay, so gantikan saja di sini hydrogen, okay, 0.02 square over hydrogen is 0.005 times 0.015. So we get 5.33. Jadi sekarang kita compare apa? Q compare with Kc. Jadi Q is 5.33, Kc is 4.1, exponent negative 3. So obviously Q is greater than Kc. Jadi if Q is greater than Kc, jadi kita tengok di manakah arah dia. Alright, so lukis Batman. So Batman bergerak ke mana? Sebelah kiri, shift to the left. Jadi bila Batman shift to the left, maksudnya the system, okay, is not at equilibrium. Jadi macam mana dia nak mencapai keseimbangan? Okay, thus reaction will shift, okay, to the left. Okay, dia akan bergerak ke sebelah kiri lah kalau ikutkan daripada sistem Batman kita di sini. Dia shift to the left. Okay, alright. So in order to achieve equilibrium, okay, so that's all. Okay, untuk kita compare Kc dan juga Qc. Right. So question number 12. Alright, so now we proceed to question number 13. Okay, so the question asks you to determine whether more CH3Cl or CH4 is formed. Alright, so what we are given in the question is CH4 plus Cl2 gas produce CH3Cl plus HCl gas, and Kp given is 1.6 exponential 1.6 exponential 4 at 1500 Kelvin. So in the mixture, the reaction mixture is given for CH4 is 0.13 atm, for CHCl is 0.035 atm, for CH3Cl is 0.24, and for HCl is 0.47 atm respectively. Determine whether more CH3Cl or CH4 is formed. So maksudnya kalau the reaction is proceed, okay, if the reaction is proceed, it will produce more CH3Cl. If the reaction is reverse ataupun shift to the left, it will produce more CH4. Okay, so apa yang kita perlu buat adalah we compare the value of Q, okay, and compare with Kp. So now write the expression, okay, untuk cari Q. Q is equal to partial pressure of CH3Cl times partial pressure of HCl over partial pressure of CH4 times partial pressure of Cl2. Jadi kita gantikan saja nilai-nilai yang kita sudah ada di dalam question. So for CH3Cl 0.24 times HCl is 0.47 over CH4 0.13 Cl2 0.035. Jadi kita akan dapat Q is equal to 24.79. So Kp, okay, the value of Kp is 1.6 exponent 4. Jadi siapa lebih besar? Okay, Kp is greater than Q. So if Kp is greater than Q, so the Batman dia akan bergerak ke sebelah kanan. So reaction will shift to the right. Jadi kalau dia shift to the right, okay, shift to the right, yang banyak di sebelah kanan adalah apa? CH3Cl. Jadi more CH3Cl is produced. Alright, so that's all for question number 13. Okay, so now we proceed to question number 14, Chatelier principle. What is stated by Chatellier's principle? Okay, so Chatellier's principle states that when a chemical system is disturbed, it retains equilibrium by undergoing a net reaction that reduces the effect of the disturbance. Okay, dia menyatakan bahawa apabila sistem keseimbangan telah diganggu, dia akan memperolehi semula keseimbangan dengan melalui tindak balas yang akan mengurangkan kesan terhadap gangguan tersebut. So that is the principles of Chatelier. Alright, so next kita ada satu tindak balas iaitu C2H6 produce C2H4 and H2. Right, so by using Chatellier's principle, I explain the shift equilibrium position, if any, of the reaction. If, number 1, the concentration of hydrogen gas is decreased. Okay, so kita kurangkan concentration hydrogen gas. Jadi hydrogen gas, okay, terletak di sebelah mana? Okay, hydrogen gas terletak di sebelah kanan. So we reduce, okay, the disturbance, kita kurangkan concentration of hydrogen. The equilibrium will shift to the right. Kenapa dia shift to the right? Because when the concentration of hydrogen gas is decreased, the equilibrium will re-establish to increase the concentration of hydrogen gas. Jadi dia akan move to the right untuk produce lebih banyak apa? Hydrogen. Right? So that's the first question, number 1. Okay. Next, if we reduce the temperature, okay, the temperature is lower, and then we add the catalyst. Okay, so if temperature is lower, kita rendahkan suhu. Okay, so temperature is ada kaitan dengan apa? Exo dan juga endothermic. Jadi kalau positive means, okay, positive means heat is absorbed. Jadi kalau heat is absorbed, it is endothermic. Okay, endothermic. So kalau positive, heat is absorbed, jadi kita letakkan heat di sebelah mana? Okay, kita letak pada sebelah reactant. Okay, so you put heat at the reactant side. Bila heat at reactant side, okay, kita lower the temperature. Jadi bila kita lower the temperature di sini, meaning that kita reduce the heat. Jadi bila kita reduce the heat, okay, heat di sebelah kiri dia akan berkurangan. So system akan, okay, shift to the left because the reaction is endothermic. So when the temperature is lower, the equilibrium will re-establish to increase heat. So equilibrium moves to the left. Dia akan bergerak ke sebelah mana? Shift to the left. Okay, sebab dia kurangkan temperature. Alright, so next adding of catalyst. So catalyst, okay, dia tiada kesan terhadap, okay, equilibrium position. Dia cuma menyebabkan the reaction react faster. Okay, so the function of catalyst to make the reaction faster. Right, jadi tiada pergerakan, no change. Next, decomposition, okay, of ethane, okay, kita akan remove C2H6 daripada sistem. So bila kita remove C2H6, meaning that the concentration di sini akan menjadi apa? Rendah. Okay, so bila concentration di sini menjadi rendah, dia akan shift to the left. Kenapa dia shift to the left? Sebab di sini sedikit, jadi dia nak tambah dia macam mana? Dia akan shift to the left. Jadi dia akan react semula C2H4 dengan hydrogen dan dia akan bergerak ke sebelah kiri. Okay, shift to the left because when we remove C2H6 daripada sistem, the equilibrium, okay, will re-establish, okay, untuk menghasilkan lebih banyak C2H6. So the equilibrium will move to the left. Okay, dia akan bergerak ke sebelah kiri. Right. Then the last one, next one, 5. Okay, volume of container is increased. So if we increase the volume of container, okay, bila kita increase the volume of container, meaning that dia akan pergi ke arah, okay, more sides. Okay, more sides. Jadi di mana yang lebih banyak? Di sebelah kanan. Okay, di sini kita ada 2 moles, di sini kita ada, kiri kita ada 1 mole. Jadi dia akan shift to the right because bila volume container is increased, okay, it lowers the pressure of the vessel and the equilibrium will re-establish to increase pressure. So the equilibrium dia akan shift to the, move to the right. Okay, untuk question 5. Right. Next one, the pressure is increased. Jadi bila kita pressure is increased, okay, when pressure is increased, volume will decrease. Jadi bila volume is decreased, dia akan pergi kepada apa? Side yang mempunyai less moles. Jadi di bahagian mana yang less moles? Di sebelah kiri. Okay, so dia akan shift to the left. Okay, so when pressure is increased, the equilibrium will re-establish to decrease the additional of pressure. So the system will move to the left. Alright, so the last 2 question. Kalau kita masukkan inert gas at constant pressure. Jadi di sini inert gas is added at constant pressure. So kalau constant pressure, okay, volume of the mixture akan increase. Okay, because constant pressure bermaksud volume dia tidak constant kan. Jadi bila constant pressure dia masukkan inert gas, okay, dia akan menyebabkan, okay, the pressure will, volume will increase. Jadi bila volume is increase, okay, dengan peningkatan volume dia akan menghasilkan lebih banyak apa? More moles. Okay, jadi bahagian yang more moles di sebelah mana? Di sebelah kanan. Jadi dia akan shift to the right because the volume of the mixture will increase. This will cause the partial pressure of the reacting gases to decrease. The overall pressure of the equilibrium mixture will thus decrease. So the reaction will proceed to the reaction that will produce more moles of gas to increase the pressure of the system. Okay, so dia akan bergerak ke sebelah mana? Ke sebelah kanan. And then if inert gas is added at constant volume, so tiada perubahan because adding an inert gas at constant volume does not change the partial pressure of the substance involved in the reaction. Jadi inert gas at constant volume, no change. Okay, because this one is constant volume. Okay, this one is constant pressure. Okay, so kalau constant pressure, volume will increase. Jadi kalau constant volume, dia tiada sebarang perubahan. Jadi kalau ini dia akan pergi kepada bahagian yang apa? More moles, more mole sites. Alright, so that's for question number 14. Alright, so next for question number 15. The Haber process is represented by this equation, iaitu process is occur between nitrogen and hydrogen. Okay, 1 mole of nitrogen react with 3 mole of hydrogen and produce 2 mole of ammonia, and delta H is negative 92.9 kilojoule. So kalau negative meaning that this equation is exothermic. Kalau exothermic, heat is released. Okay, heat is released. Jadi kalau kita release, kita akan letakkan heat di bahagian product. So its feasibility depends on choosing condition under which nitrogen and hydrogen reacts rapidly to give a high yield of ammonia. At 25 degrees Celsius and atmospheric pressure, the position of equilibrium favor formation of ammonia. Based on Chatelier principle, explain how the product could be increased. So macam kalau kita nak product more, jadi kita akan shift to the right. Okay, because we want to produce more product. More product is at the right hand side. So we want all the process, okay, menghasilkan lebih banyak apa? Lebih banyak ammonia. Okay, shift to the right. Right. So the first one, okay, kita akan decrease the temperature. Because bila kita decrease the temperature, meaning that kita akan remove heat. So when we remove heat di sini, heat ialah di bahagian mana? Heat adalah di bahagian product. So bila kita remove heat di sini, system will shift to the right. Okay, so reaction is exothermic. Decrease the temperature will shift equilibrium to the right. Next, we increase the pressure ataupun kita decrease the volume. Because kenapa kita increase the pressure? Bila kita increase the pressure, volume automatic akan decrease. Jadi kalau volume decrease, dia akan pergi kepada sites yang mempunyai less ataupun fewer number of mole. So the reaction will shift to the right, the amount of product will increase. Okay, jadi jumlah produk akan semakin meningkat. Sebab apa? Shift to the right. The next one, okay, dari segi concentration of ammonia and hydrogen. Okay, so next one, addition of nitrogen and hydrogen. Jadi bila kita increase the concentration of nitrogen and hydrogen, okay, di sebelah kiri, okay, at the right hand side, left hand side. So adding of reactant, dia akan shift the equilibrium to the right. Dia bila akan shift to the right, dia akan consume more nitrogen and hydrogen added, so it will produce more ammonia. Right. And then the last one, we remove ammonia. Okay, bila kita remove ammonia, product will shift to the right. Okay, the equilibrium will shift to the right. Kenapa dia shift to the right? Because ammonia telah habis. Okay, telah hilang di sebelah kanan. So dia akan shift to the right. Alright, so that's for question number 15. Alright, so now we proceed to question number 16. Okay, so kita ada decomposition of hydrogen sulfide, NH4HS, okay, is an endothermic process. Then you are given 6.8 grams of sample of solid is placed in an evacuated 4 liter vessel at 24 degrees Celsius. After equilibrium has been established, the total pressure inside is 0.709 atm. Some solid remains in the vessel. What is the Kp for this reaction? Determine percentage of the solid has decomposed. Jadi, if the volume of the vessel were double at constant temperature, what will happen to the amount of solid in the vessel? And what happen to the percentage of dissociation alpha? Right, so first of all, okay, kita boleh kira nilai Kp, okay, based on the equation, okay, daripada equation. Right, so kita ada NH4 HS solid, okay, dissociate to NH3 gas plus H2S gas. So pressure initial in atm, pressure change and pressure at equilibrium. So for solid pressure semua kita letak dash di sini. Okay, so this one initially is 0, 0. So this one is x. So x. Then this one 0 plus x is equal to x. Equal to x. So P total equal to, okay, partial pressure of NH3 plus partial pressure of H2S, which is equal to 0.709 atm, which is equal to x plus x ataupun 2x. The x is equal to 0.709 divided by 2. Okay, so kita dapat 0.3545 atm. Thus, untuk kira Kp, okay, Kp is equal to partial pressure H2S darab partial pressure NH3, which is equal to 0.3545 square. Okay, x square. Okay, is equal to x times x. So we got 0.1257. Okay, ataupun 0.126. So ini adalah nilai Kp. Okay, next, determine percentage solid has decomposed. Okay, soalan yang seterusnya, kira percentage solid yang decompose. Jadi untuk kira percentage solid decompose, first of all kita kena calculate bilangan mol. Okay, bilangan mol ammonia NH3, which is equal to, using the formula PV over RT. So the pressure is 0.3545. 3545. And then the volume is 4, given 4 liter, over R 0.08206, and the temperature is 24 plus 273. So kita dapat 297 Kelvin. Okay, so calculate the number of mole. We got 0.0566 mole. Okay, so this is number of mole. Jadi kita tahu bilangan mole ammonia equal to bilangan mole H2S. Okay, jadi equal to 0.0566 mole. So we can calculate the mass. Okay, mass of ammonia, mass of NH3 equal to 0.0566 times 17. So this one is molar mass for ammonia. Okay, so for ammonia we got 0.9622 grams, while mass of H2S is equal to 0.0566 times 34. Okay, so this is the molar mass for H2S, iaitu kita akan dapat 1.924 grams. Alright, so the total mass, okay, total mass equal to mass of ammonia plus mass of H2S. Jadi kita tambahkan saja 0.9622 grams plus 1.924 grams. So we got 2.88 grams. So percent decompose. Okay, percent decompose untuk yang ini, okay, is equal to 2.88 grams over So initial dia bagi 6.8 grams times 100%. So we got 42.35%. Okay, next. Okay, kita dah kira KP, kita dah kira percentage solid decomposed. So if the volume of the vessel were double at constant temperature, what will happen to the amount of solid in the vessel and what happen to the percentage of dissociation alpha. Okay, so bila kita increase okay, bila kita increase, okay, when we increase the volume, okay, twice, jadi mass dia akan increase sebanyak 2 kali ganda. Jadi mass yang increase, yang baru, okay, for this part, untuk yang di sini, so new mass sama dengan 2 times 2.88 grams. Okay, yang kita dah kira daripada part asal tadi, yang di atas. Okay, so we got 5.76 gram. Jadi thus, okay, amount solid yang tertinggal, okay, the amount solid remain okay will be, okay, so yang asal kita ada 6.8 tadi minus 5.76 grams, so we got 1.04 grams. Okay, right, so yang ini yang apa, left in the vessel. Okay, and then percent decompose yang baru pula kita boleh kira. Okay, percent decompose, okay, iaitu yang sudah decompose tadi sebanyak 5.76 over 6.8 times 100%. So the new kita akan dapat 84.71%. Okay, so that's all for question number 16.